Hello, Dr. Barnes here. So let's take a look at sampling theory. Okay, sampling theory. Okay, now let's see how sampling actually is being done. Okay. So now, normally, what we have is we have a continuous time signal like this. Okay, so this is a continuous time signal. Okay, so here is what x of t. The signal is defined at every instance of what time, x of t. So ct means continuous time, and then here is what time. Okay, now when we are doing sampling, okay, what we do is that we take impulse train signal. So this is an impulse train signal. Okay, an impulse train signal. Okay, let's see delta of what n. Here is, let's see what n, and then the impulse train signal is like this. It's an impulse train signal. Okay, so when we take an impulse train signal like this, then we multiply the CT signal. This CT signal, it is called message signal. Okay, this is called what? Message signal. Then we will multiply the CT signal with the impulse train signal. This one is called what? Impulse what? Train signal. Okay, so we will multiply the CT signal with the impulse train signal. Okay, so when we multiply them, then we will get something like this. Okay, then we get something like this. So now you see that basically this one is what? It's a discrete what? It's a discrete time signal. Okay, it's a discrete time what? Signal. Let's see, here is what? U of what? N. Okay, and then let's see, here you have what? N. You see that in this particular signal, it is defined for every instance of what? Time. Okay, so if you multiply the message signal and your impulse train, then you get the discrete time signal. Now you see that this signal here is the exact representation of this one. Okay, exact representation of this one. By taking samples from what? Samples from this one, we are able to get this. By multiplying this message signal with the impulse train signal, we get the discrete time signal. Okay, so normally that is what is being done. Okay, one thing is that the impulse train signal, okay, this impulse train signal, all right, it must actually have a time period. Okay, the time period is called what? TS. Okay, TS, and then TS. Okay, TS will give us what? Fs by taking 1 over what? TS. Okay, so now this impulse train signal, it has what? Time period. That is the period between what? The sample. The period between what? The sample. That is the time period. And 1 over TS will give us what? Fs. And Fs is called what? Fs is called sample frequency. Okay, Fs is called, Ts is what? Is the sample period, or the period of the impulse train signal, and Fs is the what? Sample frequency. Okay, Fs is sample frequency. Okay, okay. So it's called what? The sample frequency, or the frequency of our impulse train what? Signal. Okay, the frequency of our impulse train signal. And what is always important is that our Fs should be greater than or equal to 2 times our what? Fm. It should be greater than or equal to 2 times our Fm. That here, 2 times the highest frequency of the Fm. Okay, here it should be what? Highest frequency of the what? Of the FM. FM means what? Message frequency. The frequency of the message signal. Okay, so FM here is the frequency of the what? The message what? Signal. Okay, so the sampling frequency that should be 2 times higher than the highest frequency of the message signal. Okay, so let's see a message signal. A message signal. Let's say that our FT. Let's say that our FT is a sinusoidal signal. A sinusoidal signal will have several what? Frequency. For example, it can be what? Sine 2 pi t. Okay, plus sine 3 pi what? T, plus sine 4 pi what? T. See, each of these ones has a frequency. If you take the first one, what can we get? Okay, if you take the first one, we can get here, let's say omega 1 is equals to what? 2 pi. Here we can get what? Let's say omega 2 is equals to what? 3 pi. Here we can get, let's say, omega what? 3 is equals to what? 4 pi. Okay, 4 pi. Okay, so here in the first one we can have what? 2 pi what? F1 is equals to what? 2 pi. Okay, in this case my F1 is equals to what? 1. Okay, my F1 is equals to what? 1. Okay, in this one I can say that 2 pi what? F2 is equals to what? 3 pi. Okay, in this case my pi will cancel pi. Okay, my F2 is equals to 3 on what? 2. Okay, 3 on 2. I can also have 2 pi F3 is equals to what? 4 pi. In this case, my what? F3 is equals to my S3 is equals to what? Will be equals to 2. Okay, so you see that it can have what? Several frequency. So now I will take the highest frequency. Okay, I will take the highest frequency. So now you see that my FM. Okay, now let me say that my FM. Now my FM is equals to what? Maximum. Maximum among what? Maximum among F1, F2, and F3. Okay. Here, so the maximum one among them is what? Is 2. Okay. So here the maximum one among them is this 2. Okay, because here is 1, 3 on 2. Here is 2. So the maximum one is what? It's equals to what? 2. Okay. So in this case, I will take what? Fs greater than or equals to what? 2 what? Fm, which is equals to what? 4. Let's say 4 what? Hertz. Okay. So that is what we mean. Okay. So that is what we mean. Okay. So now we also have what is called Nyquist rate. Okay. We also have Nyquist rate. Okay. And the Nyquist rate, it is given as what? Fs is equals to what? 2 what? Fm. Okay. So the sampling frequency you take is very, very important because it will help you whether your signal, you can be able to reconstruct your signal or not reconstruct your signal. So, for example, in this particular case, if I want to reconstruct my signal, it's very possible because if you see what I have here, is the exact representation of the original signal. So I can easily get my original signal from what? From this one, back like this. Very simple because it's the what? Exact what? Representation. Okay, is the what? Exact representation. Okay, is the exact representation. Okay, but so to be able to reconstruct your signal depends on your sampling what? Frequency. Okay, depends on your sampling frequency. So what happens is that you see that Fs is equals to 1 over what? Ts. Okay, so what this one means is that if Fs is let's say decreasing, okay, then your Ts is what? Increasing. Okay, so depending on the Ts you take, okay, so if your Ts is, let's say, very very low, okay, if your Ts is very low or very high, it will what? Affect your Fs because they are vice versa. Okay, so let us see. So let's take a look at this. Let's say that I have this signal here. Okay, let's say that I have this signal here. Okay, like this. Okay, so let's say I have this signal here. Okay, and then let's say I take high time period. Okay, high time period. Okay, so high time period means that the time is what? Very wide apart. Okay, so let's say I take let's say one here, and I come and take another one here, and I come and take another one here. Okay, let's say I take it like this. Okay, n. Okay, let's say delta of what? N. Let's say I take my my impulse train to be this way. Okay. Excuse me. Let me take this one again. Okay. Please. I think I don't have to do it this way. Let's say that I have this one like this. Okay. Here is what? T. Here is what? X of what? T. So here is my what? Message signal. Message signal. And I take high time. My period is wide apart. My period, they are very wide apart. Okay. So my period, they are wide apart. So here delta of what? N. And here N. So they are wide apart, like let's say here, let's say here, and let's say here. Let's say they are wide apart like this. Okay. So now here, if I multiply my impulse train, this is my impulse train signal, okay, with my message signal. So here, let me write here impulse what? Impulse train what? Signal. If I multiply my impulse train signal with my message signal, this is the signal I'll be able to construct. Maybe I can have here like this, and I can have here like this, and then this one, because this space is down, this one will come what? Down like this. Okay, here is N, here is what? X of what? N. Okay, you see that this signal is not the exact representation of this one. Okay, this signal here is not the exact representation of this one. So to be able to construct it, I'll find it what? Difficult. I'll find it difficult to be able to what? Reconstruct this one, to be able to reconstruct this one from here. Okay, because here, which shape is it going to take? Am I going to say that it's like this? okay, then it comes down, then it goes this way, okay, or am I going to say that it's what, like this, okay, it's difficult, okay. So now that means that your frequency, okay, your sampling what frequency, okay, which depends on your what, which depends on your period is very what important. How you select your period and you select your frequency is very what important, okay, in the reconstruction or in the construction of your signal, okay. All right, thank you so much. We will continue in the next lecture.